I think that's all what I have. I hope that it gave you, and I want also to see if you have questions, if you have to leave some minutes for questions. Okay, I'll check now to see if there are questions. Okay, I have 80% of what? I return back to this slide. They say the for computing, okay. Okay, so there is a question on the difference between the MEC and the fog computing. Okay, we don't need to compare them. MEC was there since several years and before the boom of IoT, and it was for a specific purpose, which is enhancing services over telcos network, and so creating a sort of processing at the access level to save resources, to help operators to save network resources, that and to enable better user experience for mobile users. That was the idea of MEC. With IoT, MEC now is covering IoT ecosystem also with this same purpose, but instead of being limited to mobile users, it's for all IoT devices. When fog came, Open Fog Consortium and the notion of fog computing, fog is speaking about pushing the resources closer or extending the cloud resources closer to the sources of data. This can be the MEC, and more than the MEC, more to the edge, meaning going more to the edge, creating, if we go to this, one of the figures can show more how this can evolve. Here, for example, we look at the cloud as the notion of pushing the cloud from the data center down until being as close as possible to the sources of data that can come from a car, from an industrial environment, from home. So IoT gateway is an example of a fog element. Okay, that's not an MEC. That's really in the local network and in the proximity of these devices. So that's a fog element. MEC is the access level. Fog includes extends the cloud, and it can cover the access level and lower than the access level, which we call pre-access level even, as the gateways. You can think of, for vehicles, we can have an equivalent here, roadside unit, which is pre-access, which is before the E node B. The vehicle itself is equipped with a gateway, which is, and it is being shipped right now for high-end vehicles are equipped with gateways, which for a lot of processing and intelligent features, like the ADAS systems, and so that's considered as a fog element. So think of a fog as extending the cloud to cover the whole network infrastructure, reaching the access, which can be here the access and the MEC server, and going down pre-access even. So hope that this clarified, but I would say there's no need to say what is this versus that, because MEC has a specific scope and fog is using MEC, is leveraging MEC, but is extending the whole notion of edge processing. There was another question on network function virtualization. So network function Network function virtualization, I spoke about it with the MEC, and also in this big picture, of course, there is a big opportunity for software-defined network and network function virtualization. That's the whole idea of MEC and even OpenPOC consortium are speaking about that, are speaking about virtual machines and software-defined features for the network and virtualized switches. So the idea is IoT is more and more requiring network function virtualization and for edge compute. Not sure if we can take one more question. I think the presentation, someone asked if the presentation can be sent. Yes, I think with the organizer, the materials will be ready to deliver, no problem. Egyptian market, IoT impact on Egyptian market. Yes, okay, that's a good question, a very good one. And actually, I had some discussions with some companies, mainly around video surveillance. And so Avid Beam company, maybe you spoke about, you spoke with Avid Beam, I'm sure, before. So the idea is for the Egyptian market, I think video surveillance is a very compelling market because video surveillance is required. We need video surveillance in any market, any segment. But in Egypt, there will be the bottleneck, the network bottleneck problem will be more critical. So how to deal with the network bottleneck? If we have, for example, take a city like Cairo and try to deploy video surveillance in different areas in Cairo, touristic areas or any other selected kind of areas, and let's count the number of cameras, IP cameras that we will deploy, and the video feeds if it's 24 hours a day. So there will be a big volume of data. How can we send this data to the video management system on the cloud? That would be something very expensive. Maybe it wouldn't be real time. So here, edge and fog compute is a very useful approach to connect several cameras to one gateway, and this gateway can filter the video, can run analytics, and can send to the cloud what's needed, the relevant scenes, or even the result of this video if there is something critical or not. So that will be the problem of transforming big data into small data, and for a heavy volume use case. Other than that, I think that the okay, how can we say that? Asset tracking. Asset tracking is another very good opportunity also, because asset tracking, the solution that we deployed right now, these are not expensive solutions. It's a small piece of sensor which is installed in trucks, and it has a 2G even connectivity to speak with the back-end network and for sending tracking information. For example, how many trucks entered and the ID is this sensor can be associated with an RFID to identify the truck even. So that's a solution which is not an expensive one, which allows the automation for asset tracking. What more I can see? Agriculture IoT right now is not an expensive solution. Solutions are not expensive because it requires, I don't know, something like $1 sensor or so that can be installed in the fields in different areas to test water leakage, for example, or to test dryness, to test even insect problems or so, and send this information. This information can be sent to the cloud here because it's really small information through a 2G connectivity, which is not an expensive one. What else? Future of fog computing in developing countries. Okay, that's a very good question also. It comes with something which is good, which is low cost. It provides low cost. It's not only saving network resources, but it comes with a low cost. We can for some scenarios we can count on fog and local compute and without requiring the cloud at all. Because cloud is expensive not only in terms of the network resources and the pipe to the cloud, but also in terms of monthly fees that should be paid to the cloud provider each month, or I don't know, according to how the deal is, but it's expensive. If we look at something like agriculture IoT, for example, or asset tracking, this may happen locally with a local solution without requiring any communication with the cloud. So fog computing comes with it adapts to the network infrastructure which exists. I mean, something like the IoT gateway, it is equipped with Wi-Fi connectivity, with Bluetooth connectivity, with cellular connectivity starting from 2G. I wouldn't speak about 5G right now, but it starts from 2G. And it has an Ethernet connectivity, and it can represent an enormous resources for compute, for processing, for storage. And so action can be taken directly here without going to the backend cloud. So if we look at a solution counting on a back-end platform, which is not really a back-end, which is proximate to the sources of data and a low cost, versus a solution which requires continuous communication to the cloud. We are speaking also in the Open Fog Consortium on energy windmills, for example, as a very good use case for fog computing. So I believe in Egypt, if going to this question of fog computing interest in the region, that's another use case which can be very helpful in the area if we think about windmills and coupled with fog computing.